Okay, this is gonna be our last repair for today. Um, okay, it's an A2141. It's a 16 inches. It says it's dead. A2141, 16 inches, and then it says it's dead. Okay, the 16 inches 2019s only. So this was released in 2019, and it was refreshed with the 2021 16 inches non-touch bar. I mean the newer version, which is what I have. So this was replaced with this. So this was 2021 and this was 2019. So this was sold between 2019, 2020, up until eventually 2021. They they discontinued it, and then they had to replace it with this one, and which is the M1 version of this is Intel, this is M1, and then the touch bar was also taken away. Anyway, let's get to it. Let's see why we're here. We're here because the device is in power on. As usual, the first thing we do is we take out the back cover to get to understand exactly what state our device is in. Okay, back cover is out. This is how the inside looks like. We have a bit of dust on both sides. It's expected because of the section of the board where you have air can go in and out there, and then air can also go in and out there. And over time, obviously, there will be accumulation of dust in that section of the machine. So the back screws is leaking, and the board is out. The next thing we want to do is um, we could just see if the machine is able to put into DFU, or another thing we can do is we can just quickly see if we have a short on the board. If we don't have a short on the board, we will then put the machine into DFU mode and see if revive or restore will fix the issue. And yeah, before we connect our charger, the first thing we want to do is we want to disconnect our battery. Started, and then we start by disconnecting our battery cable. That's gonna be this one here. That's gonna be our battery cable. Okay, battery cable is disconnected. Now also let us remove the battery main power line screw, which is this one. So I'm talking about this is the battery main power line. So we have to take out the screw there that holds. This is basically the battery cell. That's the battery main board, and this is where it makes connection with the logic board. Here is the battery main power line, and then this is the data line for the battery. So with the battery cable disconnected, that will obviously disable your battery from sending. So that will make your battery uh, inactive. So basically, it becomes inactive. On your board. So if you disconnect the cable, then there will be no more power going to your board. But that will be if the battery calibration is the way it should be. So what I mean by that is if it is a Chinese knockoff battery, you may have a situation where even though the battery is disconnected, the battery is still basically outputting power to your logic board. So now that we have disconnected our power, because we want to measure for a short. Now, when you're measuring for a short, you want to make sure that you don't have power, you don't have existing power on your machine. Neither should you connect a charger or the battery being connected to your machine. So if you're measuring for a short, you make sure there is no power on your board. Now we switch our multimeter to continuity mode. I hope you guys can see that. We are on continuity mode, and now we want to see if we have any short before we do anything. Let's start by checking out our PP bus so we can get to. Okay, this the board we're working on. It's an 80-01700. That is the board view of the 2019 16 inches, 80-01700. That is it. So this is the board we are working on. Well, let's flip to the other side. Now these two white components here are going to be the fuse. So those are going to be the fuse on our PP bus line. So that's which is going to be this two here. So those are sitting on our PB bus line. So what we want to do is we want to see if we have a short on those, and we don't have a short. Okay, that's fine. Now let us see if we have a short on our SSD rail. Okay, yes, we do have a short on our SSD rail, and that we were able to confirm here. So at 2.5 volt NAND, we have a short on the line of 2.5 volt, and I was able to measure for a short on these two caps here. These two caps here. Okay, show you guys. So I was able to use these two caps here to check for the short. Yes. One and two. These two here. So now the caps that I just pointed to are C9589 and C9587. So you can easily measure for short on those lines because you don't have to remove the board before you can access those caps. And I we have obviously checked to see if we don't have a short on our PP bus, because also when depending on the type of shorts that you have on the board, it can also be present on your PP bus. But in this case, the short is not present in our PP bus, but still we have a short around our NAND. Now you also see why it is also not ideal to connect power to your device until you are sure of what state the device is in. Now, for short on our NAND, it's not good. So the NAND is it's basically rated to receive below 3 volt of voltage. So the highest voltage that goes to the NAND is 2.5 volt. Now imagine because it's shorted, and then imagine it may because it's shorted, it may receive a higher voltage than what is rated for it, and that will damage your NAND. So before you connect power to your device, it is advisable to have an idea of what state your board is in before you connect power to it. Okay, now that we know that we have a short on our NAND, let us hope that the problem is not the NAND itself. Let us hope that a cap or something along that line is affected and not the NAND. Because if it is the NAND itself, so first thing, it's going to be an expensive repair. Second thing is the client will lose their data because the NAND is it's the SSD, and the repair will include having to replace the NAND. And when that happens, the files on the NAND will be lost. So we hope that is not the case. We hope it's a component along that line that is faulty, and yeah, that we'll be able to have a fully functional device after that it's addressed. And then something else I want to say. So while it's in this state, even if we try to put the device into DFU mode, we will not succeed. Even if we are able to get the device into DFU mode, we will not be able to um, successfully restore or successfully revive the device. It will always come back with an error because your DFU, part of what's required for a successful DFU is also your NAND, your NAND circuitry also has to be everything has to be up and running in the section of your NAND for you to have a successful DFU restore. So in this stage, even if we try to restore or revive the device, it's not going to work. And even if we do successfully restore or revive the device, it's still not going to work because without the SSD, the device will not start. So the 2019, the 16 inches, they are very common with SSD failures. So usually when I get, depending on if it's not liquid damage, when I get 16 inches that is now turning on, the first thing I do is I check for a short. If I don't have a short, then I'll try to revive the device. Um, and usually, if I'm able to put the device into DFU mode and I revive the device and it does not go through, usually, if revive does not work, usually, obviously, one of the reasons why I choose to revive first is because that way you get to save the client's data. But usually, should the device process should the process fail in revive mode, most of the time it doesn't work on you trying to restore the device. So yeah, uh, it's always safer to start with the option of revive and not restore, because restore will obviously erase all of the client's data. Okay, the board is out. Let's put the shell on the other side. Okay, this is what the board looks like on the other side. So our focus is going to be in this section of the board as well as this section of the board. So let's let's test the board and give it a visual inspection. See if anything is standing out that is worthy of concern. Okay, so there is a bit of oxidation in this section of the board here, and also that cap, this one here, that's not looking good. That is not looking good. This is also not looking good, but mine sitting on the PP was real, and the PP was is not shorted, so we're not really worried about that. Let's see if I can focus. I'm worried about this cap here. So this one here. That's not looking good. And that cap is sitting on, let's see what that cap is. Let us flip our board to the other side. So that cap, that is C9586. So that is definitely sitting on the PP2 PP2V5 underscore NAND. So that is definitely sitting on the line that we have a short on. So let us remove that cap and see if we have any changes. This is the second cap that also looks funny on one side of it, but because it's a PP, that cap is sitting on the PP bus voltage line, we are not really worried about that cap right now. So let us see if removing C9586 will solve the issue. Let's just hope that it solves it, and let's just hope that none of our NAND is the issue. Okay, the cap is out of the board. I'll show you guys that. So the cap is out of the board. Next thing we want to do is let's see if we still have a short. Before we check if we still have a short, let us see if we let's measure on the cap itself and see if the cap is shorted. And alhamdulillah, the cap is shorted. That is good because that tells me that most likely my short will no longer be present on the board. Now let's measure and see if we still have a short on the board. Okay, now my short is gone. I no longer have a short on my board. So the only problem was that cap that was not looking good. Now the cap is out of the board. We no longer have a short on the board. So that's pretty much what our problem was. So right now we will also replace C9581 just so that it doesn't fail in future. But right now, like I said, we do not have issue with it. Let's get a donor board. Okay, so we have replaced C9586. The next thing we want to do is now that the cap is out and then the cap has been in place, let us hope that U9580 was not affected in any way. So one of the ways we can confirm that U9580 was not affected in any way is if we have the output which is supposed to be generated from U9580, sorry, U9580, which is 2.5 volt. So if that is present, that tells us that U9580 was not affected. So let us clean that section of the board and then we can test it. Okay, now let's see if we have any changes. And let us hope that U9580 was not damaged in any way. Let's switch our multimeter to voltage mode. Let's measure at L9580 and see if we have 2.5 volt. And yes, we have 2.5 volts. So that is good because it tells us that U9580 was not affected, and it also gives us an indication that most likely our logic board is working now. So the next thing we want to do is we want to uh, uh, install the board in our shell just to see if we have Apple logo. See if the machine boots the way it should. Afterwards, the machine will go into the regular testing after it's been assembled, and then the client can be informed to have a happy working machine. I like to adjust the and the guys. So this usually, if you have to use this, you have to be very careful. It's always better to use a blower. And each time I'm busy on my desk, I get so lazy not to go grab a blower instead. Because when you're using this, you have to be careful not to rip out any of the cables. Okay, that is done. Now let's install our board and see if we have any changes. I don't need all the cables connected for me to boot the machine to desktop. I just find it more convenient to have all of the cables connected. And with the 16 inches, you almost always miss out a cable, especially the fan cables. Okay, we're almost done here. So we will install the battery screw and then another two to hold the board in place. And then the battery screw. Sometimes when you have a situation when you have a situation like this, the board might go into recovery. So in that case, you have to revive it and also hope that nothing nothing go wrong with the NAND chip. So now that that has been done, the board is in. Let's now connect our charger and see what we get. Charger is connected. See, check for trackpad feedback. We have trackpad feedback. Let's see if we have fan spin. Uh, we don't have fan spin yet. Yes, we have fan spin, which is good, but no Apple logo. Okay, so this is always something that I do. Whenever I'm testing, I always don't have the cable connected. I don't know, for some reason, it's just something that I always forget to have the cable connected, which is, I'm talking about the screen cable, by the way. So most of the time when I'm testing, I do not connect to the screen cable. So I forget to connect the screen cable, and then I have to obviously stop and then reconnect the screen cable again. Okay, so let's try that again. Let's connect our charger. See if we have spinning fan. Okay, we have fans are spinning. Let's see if we have an Apple logo. Yes, not an Apple logo, but a charging battery sign. So that tells us that our machine is working. So we just close the machine a bit, give it a bit of time, let's say 2 3 minutes for it to charge, and then we can now check it out again. So what was the issue? So our issue was C95 86. Let's open up the schematic and see if you guys let's see. Uh, okay, so U90, yeah, U9580. This is U95. We had a problem in this section of the board. So the two inductors here, this chip here is supposed to take in PP bus voltage, and then this is going to be a buck converter. It's going to basically it takes in a high voltage and then outputs a low voltage. So it takes in PV bus voltage, and obviously when there is an enable signal, so provided the conditions are met with the condition, the working conditions of U9580, then it will output 2.5 volt, which is here. Now that what we had was we had a short on our 2.5 volt. Now the 2.5 volt is supposed to go to our SSD, which is the NAND, and those that we had a short on that line, and as a result of that, the machine was not starting. So we took out the board. Obviously, like we always do, before we connect our charger to the device, we make sure that we are able to establish the state of that device. Just to be safe that it is okay to connect power to that device. So before connecting power to the device, we had to measure for short. We checked on our PP bus, PP bus line there was no short, and then we checked on our PP2V5, which is the NAND line, and we found the short. And then one of the reasons why I did that was because this is a common failure on the 16 inches 2019. So when I get a 16 inches like this one, and then like I said, if there was no short, the next thing I was going to do was going to be for me to try to put the machine into DFU mode. When I do put the machine into DFU mode, I will first take the option of revive and not restore, because restore will erase the contents of the drive. So I will take the option of revive first. Should that work, then the client will have their files still intact, and then the machine will be up and running. But in this particular case, we found a short on our 2.5 volt line for the NAND. We took the board out and narrowed down the short to C9586. Now, something else. So, because there is, so usually when you flip the board to the other side, so when you flip the board to the other side where that cap is, usually you will find that there will be a bit of a mixture in that section of the board. So I'll show you guys what I'm talking about now. So on both sides of the board, there, because of the outlet here, this. Now, on both sides of the board, you find a bit of a form of some kind of oxidation in that section of the board. And then what also happens, and over time, then the section tends to corrode. And that section of the board, that's where you have, that is the circuitry for your NAND. And then when that section starts to corrode, what happens is either this cap will fail or that cap will fail, or sometimes even U9580 will fail itself. Because I had a repair, I think in this same week, that U9580 was among the components that failed. It was exactly the same scenario that we're having now. And even with that one, after the repair was done, we had to revive the device. The device went into recovery, and then we had to revive the device. So pretty much that was what we did, and as we can see, our device is now up and running. So we had to plug it for OP to see if we will get a bit of juice on our battery. Let's now see if we have a bit of juice on our battery. Still charging. Okay, that's fine. We'll just leave it to charge. And then, I'm not sure why the battery is completely. And I'm definitely using the same charger for my 16 inches, which is more than enough in terms of wattage. And also for this machine, you want to use a 96 watts charger and not 87 watts. If you want to use 87 watts, you can use 87 watts if you have juice on your battery. But if you don't have juice on your battery, it is advised to use a 96 watts, and it should be an original Apple charger. So guys, I'm just gonna leave this to charge a bit, and yeah, and then I mean, as far as we have the not charging sign on the screen, it tells us that the machine is actually starting, because if it wasn't starting, we will not even get the low battery sign on the screen. If that happened to be a problem, for example, if the battery it's a problem, or say if we have a charging issue, then we can always address that. But for now, we just leave the device to charge a bit, and I will show you guys after the device is charged. For now, thank you guys. I will see you after the device is charged. And then as far as the repair is concerned, the repair was successful. We just want to charge the device a bit, and then I will show you guys after the device is charged. Thank you. I'll see you guys after the device is charged. Okay, guys, as you can see, just close that. Now we have a bit of okay, I'm not sure you guys can see that. So that's the device. The device is I. I'm trying to cover the username of the client. So the next thing we want to do is give it to charge a bit, and then yeah, pretty much that was it. And this is a completed repair. So thank you guys. I will see you guys in the next one.